Welcome back to The Explainer. So, today we are diving into a topic that honestly completely upends how most of us think about communicating with artificial intelligence. If you've ever spent hours, and I mean hours, agonizing over getting the exact right facts and figures into your AI prompts, well, you're in for a treat. Let's peel back the curtain and look at what actually makes a great AI prompt tick: format and labels. Let me just start by asking you a quick question. Do your AI prompts actually need perfect facts? Intuitively, it makes total sense, right? If you're giving a large language model an example of how to do a specific task, that example should be flawlessly accurate. I mean, you wouldn't teach a kid math by giving them the wrong answers, so why on earth would we do it with a highly advanced neural network? Well, prepare yourself, because that assumption is about to get completely shattered. Normally you'd think, okay, to teach an AI basic math formatting, you'd prompt it with a perfectly logical example, something like, what is 2 plus 2? 4. But get this, consider a completely absurd alternative. What is 2 plus 2? 50. Now, surprisingly, the research we're looking at today proves the AI doesn't actually care that 2 plus 2 isn't 50. There's no way, right? But using that absurd example won't break the model's performance at all. Let's dive into exactly why that happens.
All right, let's jump right into section 1, the ground truth myth.
Now, when AI researchers throw around the term ground truth, they're really just talking about the actual, factually correct answers, the real-world facts. The ground truth of 2 plus 2 is 4. The capital of France is Paris. We have all basically been operating under the assumption that ground truth is the absolute most important element of any example we feed to an AI. But here is where the research reveals something completely counterintuitive. Providing random labels in your exemplars has almost zero impact on performance. You heard me right. You can feed an LLM completely random, wrong answers in your prompt's examples, and it basically doesn't care. It will still perform the task successfully. So that begs the question, if the facts don't matter, what actually does?
Which brings us to section 2, why format is king.
To really grasp this, we first got to define a buzzword you'll hear a lot in advanced prompting circles: exemplars. Exemplars are simply the specific examples you type out within your prompt to demonstrate the output you're looking for. It's the few-shot part of few-shot prompting. Basically, you're giving the AI a template of what success looks like. Let's bring back a variation of that crazy math example from earlier. Look at what happens when you prompt an LLM with these exemplars. What is 20 plus 5? 43. What is 12 plus 9? 21. The math is, well, it's laughably wrong, but notice the format here. The answers are spelled out as words, and they are in all capital letters. When the AI generates its final response, it completely ignores your terrible math, but it rigorously mimics that all caps format.
So here's the absolutely crucial takeaway. Format completely overrides facts when it comes to your exemplars. The primary job of an exemplar isn't to teach the AI brand new facts. It's to instruct the LLM on the exact structure of the response you want. You see, these models are essentially just incredible pattern matching engines. When you give them a format, they lock onto that pattern like glue. The formatting acts as a structural blueprint, and as the research shows, this pattern matching reflex is so incredibly strong, it works perfectly even when the underlying data in your example is totally 100% incorrect.
Moving right along, section 3, defining the label space. I know, label space sounds like some heavy technical jargon, right? But it's actually a super simple, powerful idea. The label space is just the complete list of possible valid buckets you want the AI to use for a given task. Imagine you're asking an AI to sort a giant spreadsheet of restaurant reviews. Your label space might literally just be 2 buckets, positive and negative. That complete list of valid options, that is your label space.
Okay, remember a minute ago when we said you can use random incorrect facts in your exemplars? Well, hold your horses, because here is a massive, giant caveat to that rule. Random labels are totally fine if they are pulled strictly from your defined label space. For example, you can totally misclassify a glowing positive restaurant review as a negative one in your example, and the AI will still learn the format. But if you randomly classify it as pineapple, the AI is going to get super confused. Your ground truth facts can be wrong for sure, but the labels you use in your examples absolutely must exist within your established label space. This is what helps the AI understand the boundaries of the task.
All right, let's get into section 4, mastering label distribution.
Let's just stick with that restaurant review example. Picture this. The real-world data set you're analyzing has a true distribution of 60% happy customers and 40% unhappy customers. So the reality is heavily skewed toward positive reviews. See, when most of us write exemplars, we tend to use what's called uniform sampling. We naturally provide an equal number of positive and negative examples, say a clean 50-50 split. But the research points to something called true distribution sampling. You want to accurately map your label space to the real world. Mirroring reality in your prompt's exemplars gets you significantly better AI results than an even 50-50 split ever will.
To make this super practical for you, here is your concrete mathematical takeaway. If your real-world dataset is 60% positive and 40% negative, your prompt exemplars absolutely need to maintain a 3-to-2 ratio. Think of it this way. You'd want to provide 3 positive examples and 2 negative examples in your prompt. By matching the true distribution of the label space, you're implicitly teaching the AI about the actual shape of the data it's going to encounter out there in the wild. Which leads us perfectly into Section 5, the Golden Exemplar Rule. Research actually shows that using between 4 to 8 exemplars in your prompt consistently yields highly effective results. If you've just been relying on 1 or 2 examples, you are leaving a lot of performance on the table. Moving into that 4 to 8 range is the absolute sweet spot for locking in your format and your label distribution.
Now, having said that, while 4 to 8 is your baseline sweet spot, don't be afraid to go big. The source material makes it abundantly clear that including as many exemplars as possible can often be incredibly beneficial. As long as you respect your model's context window limits and you maintain your formatting and distribution rules, more examples generally mean a much more robust output.
Okay, let's take a quick breath and just recap exactly what we've learned today, because this really transforms how we should be building prompts. Number 1, format absolutely rules over ground truth. Stop stressing about the facts in your examples, stress about the structure. Number 2, while the facts can be random, the labels you use must strictly fit within your defined label space. Number 3, stop using those 50-50 splits and start matching the true distributions of your actual data. And number 4, aim for that sweet spot of 4 to 8 exemplars and push for even more if you can.
Which leaves me with one final, maybe slightly painful question to ask you guys. How many perfectly factual prompts have you wasted time writing? Think about all those hours spent agonizing over getting the exact right data into your examples when all the AI really wanted was a clear format and a well-defined label space. It's incredibly freeing, isn't it? Actually, scratch that, it's a total game changer. You can now abandon the old, slow way of writing examples and test out this faster, format-first methodology right now. I seriously can't wait for you to try it out in your own workflows. Thanks so much for joining me on this explainer, and keep on learning.